All right, this is Math 5, Week 6. You did it, you finished. Quiz 2 in 5th grade geometry, that's what we're going to look at. Quiz 1 was a doozy, but it was good. It's good. Now quiz 2, oh man. See, now I had already did this one, so now we're just gonna start it over. All right. Don't recommend that, by the way. I know people get one wrong and then they just want to get it all wrong and start it over. So I think you can learn more if you don't do that. But I'm trying to teach you here. Anywho, Bruce bought the enormous box of juice shown below. Each day he plans to drink 630 cubic centimeters of juice. How many days will it take Bruce to drink the juice? So let's pull out the key information, obviously the number 630, but the units are cubic centimeters of juice. And that's a total, right? That's the total amount of juice. And no, that's not the total. Now I'm reading it more carefully. That's each day. And each day you plan. Oh. Okay, so he's gonna drink 630 each day, but we don't know how much juice there is total. So what do we got to do? Per day, ounces per day. We got to find the volume. All right, so we got all our units are the same. That's nice here. My calculator has batteries. That's nice. And so let's find the volume of this rectangular prism. Rectangular prism. Volume is base times, oh man, we're going to have to use the old length times width times height. I love to think about volume as base area times the height, but we'll just say length times width times height. So what's the length? The length would be the 10.5. So I'm going to change that to 10.5. The width is 20. The height of this prism is 30. We're going to multiply those numbers together. Go ahead and do that for yourself. Don't rely on me. Well, I get 6,300. Okay, so he's drinking 630 per day. So this is the total and the per day amount. So if we divide those two, we're going to get the number of days. Yeah, so see, divided by 630, 10 days. I knew that. How do we know we had to find the volume? Because the volume is the total amount of something inside the container. So the total amount of juice in the juice box is the volume of that juice box. Identify the 3D shape. So hey, let's talk about our 3D shapes. And let me even show you how to draw. Okay, so we have prisms, where I draw the parallelogram. And if you draw the same parallelogram on the top and the bottom, then you get a really nice picture. But it's kind of hard to do. So that's a rectangular prism. But you can have different prisms. You can have triangles. Draw two triangles, connect them, and now you have a triangular prism. So change the base shape. Base can refer to the top or the bottom, and then that gives you a different type of prism. Trapezoidal prism, right? So lots of different prisms. But then we also have, one base, like we see here. Let me just draw. Oh my gosh, that's terrible. All right. So I didn't plan. I just did it. It's a triangular pyramid. I think it's pyramid. But then we can have, if we draw a square and then put a dot up there and then connect all the vertices to the dot, you get your square pyramid. That's what this is, a square pyramid. But then what if we have circle bases? So let's draw some circles and then connect. That is a cylinder. Very important shape. And draw one circle and connect the edges. What's that called? That's a cone. And if you draw a little dashed line right to the middle. Okay, and then the last one, everyone's favorite, the sphere. All right, so make sure you know all your 3D shapes. There's more, but those are the general ones to get you started. Now, faces. So the faces, let me outline the faces in yellow here. So these are the faces. And they all have faces, but I'll just use a different shape for each vocabulary term. These are called vertices, or each one is a vertex. Okay, so those corners are the vertices. And then we have the lined segments along the side. Those are called the edges. Okay, so how many faces does this thing have? As the bottom and then the 4 triangles, so it has 5 faces. Okay, so you can find the volume, length times width times height. Go for it. Oh, this one though, this one is a little tricky. They gave you the area. That's what I was talking about, like the base area. So they gave you that. So then you just multiply that by 4. You get it. You don't need it for that. How many cubes? Okay. So this one, what you're going to want to do is find the volume. And then how many cubes can we put in with side lengths of 1/3? So think about it like this. The volume is cubes with sides of 1. How many of those can you drop into the figure? So let's draw our unit cube. This is a dark and stormy night tonight. Isn't that crazy? And I am making math videos. All right, so this is a unit cube where each side is 1. But if we separate it like the given says into 3, right? Now we get this little tiny cube, and we can actually fit 3 along the side, and then 3 in the middle, and 3 at the top. So it's actually like 9 of these cubes. But then there's 9. So there's, of the little cubes, it would be 3 across, 3 back, and 3 up. So 3 times 3 times 3, or 3 cubed, is 27. So you find the volume, and then you multiply by 27. And that is going to be how many of these little cubes there is. Why? Because there's 27 little cubes in a unit cube. And when we find the volume, we're finding the volume in unit cubes. Units cubed. All right, so let's do this one so that you believe, because you probably like, multiply by 27. That seems made up. Okay, so let's do 5 times 4 is 20 times 2 is 40. 3 times 3 is 9. So the volume of the figure is 40 over 9 centimeters cubed. But to get the little cubes, we got to multiply that by 27. So what is our answer will be 40/9 times 27. So watch this. I'm going to put the 27 over 1, and I'm going to cross cancel. So 27 divided by 9 would reduce to 3 over 1, because 27 goes in, 9 goes into 27 3 times. And so then we just have 40 times 3, which is 120. So the volume in terms of the 1/3 unit cubes is 120. All right, and with that, you have completed the getting ready for 5th grade curriculum. Congratulations. Go into 5th grade and rock the house.